We're moving into Chapter 7-3, Triangle Similarity, and we're going to look at 3 examples, and it's going to be somewhat familiar to you, but there's going to be a huge difference. We're going to look at angle, angle, side, 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 and side, angle, side. Now, if we're proving congruency, angle, angle, of course, would not work, but we're only going to prove similarity. That means the angles all have to be the same, but the sides have to be proportional. Let's take a look at our first example. So here we have explain why similar, find measure of AB given this situation right here. We have 2 triangles. We have a small triangle right here and a much bigger triangle. And we're given that these 2 angles right here are congruent. And guess what? This angle right up here and congruent to itself, reflexive property, angle A is congruent to itself. So using one of the theorems, we can prove that these 2 triangles are similar. Therefore, we know that we have a proportional sides. And I want to do something real quick. I'm going to go ahead and move this triangle out of the way. And we could get a better picture of what our sides look like. Now this is congruent to that. So I'm going to make sure I compare apples to apples, oranges to oranges. Well, I can compare this one right here, ED, to this one right here, 15, so I have 9 over 15. And since I've proven similarity using angle, angle, I can go ahead and set up this proportion 6 over whatever AB is. I'll go ahead and write AB, call that X or whatever. And I just say, okay, well, let's just boil this down to a simple proportion. That's 3 over 5. 3 over 5 is equal to 6, just call it X, I don't care. We could cross multiply using the cross products property, or we can just say, what kind of scale factor are we dealing with? Well, it looks like kind of like 2. We multiply 2 here, and we're going to multiply 2 down here. So X is going to equal to 10, or this side is going to equal to 10. So that is 10. That maintains the proportionality. Alrighty, because 10 over 15 is equal to 2/3, 6 over 9 is 2/3, it all works out the same. Alright, so moving on. Next example. This one is far more trickier, and you need to pay particular attention to this one and work this one out on your own on a blank sheet of paper. I'm going to spend the most time on this. Verify the triangles are similar. Now, here's our most important information right here. They're not saying they're similar or anything else. We're just comparing this triangle to this triangle. And the way this is written is our key information. Look, KLM, this is our big triangle right here. KNL, KNL is this triangle right here. Notice they kind of go in different directions. Something got rotated and squished. Well, let's try and figure this out some more. If we're going to compare, we got to compare apples to apples, oranges to oranges. I'm going to say that all year long. You'll get sick of it. But let's take a look at KL. We're going to compare that to KN. Here's KL, that's 6, and KN is 4. So I can compare that to 4. And let's take another part. We can take, well, KM, and that's 9. I just add the 2 together. I'm going to compare it to, again, KL, 6. Those proportions better be the same. If they are, we're kind of in there for at least a start. So we have 6 over 4, which is nothing more than 3/2. And that proportion is nothing more than 3/2 also. Well, we got a proportion on the sides. We need an angle. We have one, and it is right here. Angle K, reflexive property, is congruent to itself. So look what we have. We have side, angle, side. Now let me go ahead and move this out of the way so you get a better picture. Here we go. Here's my small triangle, and here's my big triangle. We have this side proportional to the big side. This is proportional to that, and 6 is proportional to 9. 6 over 9 is the same thing as 6 over 4. Then we have this angle congruent to itself, right here. And we have side, angle, side. Similarity. Study this problem, redo it, think on it, and if you can handle this one, you can handle this chapter fairly well, because side, side, side is super simple. You've seen this in your Math 8 class a lot. And there's many different ways to approach a problem like side, side, side. This is number 3 out of 474. And we're going to look at this. This, again, is our important chunk of information. if we're going to compare things, we got to compare DE to JK. Now I have a habit of kind of doing all my similarities in the same way. I go from this side to that side, and I always compare apples to apples. So DE is 8, and JK right here is 16. That comes down to 1/2. So let's see if it equals something else here. Let's go ahead and take a look at EF right here and KL. So EF is 10. KL is over here 20. Well, yep, that looks like 1/2 also. Let's go ahead and do this one right. DF is 6. And JL right here is 12. They all equal to 1/2. So side, side, side proportionality. And there's more than one way to skin this cat. You can look at scale factors. Well, obviously the scale factor is a 2 because you multiply 2 to this side to get over to here, 8 to 16, 10 to 12. But what we're going to do to you is we're going to rotate these things. We're going to flip them. We're going to do all kinds of things, sometimes bury them inside each other. So you have to use this piece of information right here to make sure you're going in the right direction and comparing the right things. Alrighty, you're going to have to probably review number 2 back here. This one I think is the tricky one. And study this chapter, practice, and you'll be good for what's coming next.